Picture this. You're a young learner and you've just walked into a massive, sprawling city. Thousands of people are rushing by you. Millions of decisions are happening all at once. You've got roads, overlapping maps, shops, layered conversations. It's just this infinite, chaotic menu of choices. It's totally overwhelming, right? Well, welcome to The Explainer. Today, we're going to uncover the invisible architecture that actually makes sense of all that chaos. We're going on a journey to discover exactly how raw information transforms into true intelligence. So, faced with all this swirling chaos in the real world, we really have to ask ourselves a fundamental question. How do both the human mind, and artificial intelligence for that matter, actually manage to find patterns in all that noise? How do we take a storm of random inputs, the sheer volume of human experience, and extract a clear, meaningful path forward? Well, the answer begins with structure. You see, understanding doesn't just emerge from magic, and it definitely doesn't appear out of thin air. Instead, it comes from a highly deliberate, beautifully constructed mathematical architecture. It's a process of building meaning, step by step from the ground up, turning the wild unpredictability of the world into something a system can truly comprehend. We can actually trace how machines, and honestly human logic too, learn along this single continuous staircase. It begins the very moment human observation is converted into structured language. Think about it. We observe the world, we measure what we see, we record those measurements as numbers, and then we organize those numbers using symbols. This sequence right here, this is exactly what awakens intelligence. Think about what data actually is for a second. At its core, data is simply measurement. If we take a person's physical traits, let's say a height of 170 centimeters and a weight of 65 kilograms, we're literally turning human reality into precise numbers. Now, we haven't changed the person, and we definitely haven't lost their humanity, but we have made their characteristics readable to a machine, and that's the very first quiet step toward intelligence. And that brings us to our next big leap. Because numbers alone, well, they really only tell us how much. But think about how we humans actually manage complexity every day. We use names, maps, addresses, phone numbers. The exact moment numbers become organized by symbols, whether it's a zip code routing mail across the globe or variables like X and Y, our thinking becomes completely scalable. Symbols act like these little containers for ideas, allowing us to stop looking at individual isolated values and start seeing massive overarching patterns. Part 1. The geometry of information. Let's see how this builds from simple numbers into actual movement. Now, instead of getting bogged down in complicated algebra, I just want you to think of a vector simply as an arrow representing a journey. Imagine you're navigating that big city. You need to know two absolutely crucial things: how far to go and which way to turn. That right there is a vector. It carries both magnitude, the distance, and direction. It represents movement with intent. Let's look at how this applies to human behavior. Say someone loves action movies and comedies. We don't just dump those numbers into a flat, lifeless spreadsheet. No way. We actually map those preferences as an arrow, pointing in a very specific direction in an information space. A high score for action and comedy points the arrow one way, while a high score for romance points it somewhere else entirely. Literally, your tastes and your personality become a physical direction. And this concept is wonderfully universal. Think of GPS coordinates guiding an airplane, or the exact latitude and longitude of your favorite restaurant. But it goes so much further beyond physical geography. Everything from the exact tempo of a Spotify song, to a customer's income, to the subtle nuances of a spoken word, can be mapped as a coordinate. We are fundamentally shifting reality into structured geometry. Everything becomes a position in this massive information space. Part 2. The shape of meaning. This is where things get truly fascinating. Once everything you can imagine is plotted as a coordinate in this massive space, we really have to pause and ask, if a computer doesn't feel human emotions, and it doesn't actually have ears to listen to a melody, how on earth does it know which song to recommend to you next? Without a soul, how does a machine know that two things are actually similar? Well, the answer is wonderfully visual. Similarity becomes measurable without relying on heavy, impossible formulas. Think back to those arrows representing our journeys. Things that are alike simply point in the exact same direction and live close together in our coordinate space. A mathematical operation called a dot product just measures this alignment. If your arrow and a movie's arrow point the same way, the system knows for sure it's a match. Stronger physical alignment literally means stronger conceptual similarity. This geometric logic creates a totally magical landscape where words themselves become physical locations. Because of this, we get that famous mathematical equation in AI. The vector for king minus the vector for man plus the vector for woman equals the vector for queen. The machine doesn't have a clue what royalty or gender is in a human sense, but it knows exactly where these concepts live in relation to each other.
What you should take away from this is pretty profound, meaning in an intelligent system isn't some dictionary definition that a computer just looks up on a hard drive. Not at all. Meaning emerges entirely from the physical, geometric distances between these data points. AI understands meaning by analyzing the actual shape of information.
Part 3. Engines of transformation. Moving from single points to massive systems. Now, mapping a single vector, like one person's movie preferences, is pretty easy, but managing millions of vectors across giant, complex datasets like global weather patterns, hospital networks, or worldwide shopping habits, that requires a totally different, vastly more powerful structure. Enter the matrix. If a vector is a single raw ingredient, a single point of movement, a matrix is the entire factory assembly line. It's a massive engine built specifically to process, organize, and transform all that raw complexity at once. You see, these matrices are not just static tables of numbers sitting on a page like an old ledger. They're active, powerful engines that literally stretch, rotate, scale, and reshape entire information spaces. By warping and moving these coordinates, the matrix basically forces hidden patterns to become recognizable. It untangles this incredibly knotted web of data so the intelligent system can finally see clearly. Part 4. Predicting the unknown. This is what it all leads up to. Why do we do all this beautiful geometric transformation? Well, it's for the ultimate goal of any intelligent system, navigating the future. Whether it's a language model guessing the next word in your text message, or a medical system assisting a doctor with a complex diagnosis, it all follows this continuous, logical pipeline. Raw input is taken in, the mathematical engines calculate the distances and alignment, a recommendation is made, and then feedback improves the system for the very next cycle. When we look at global weather forecasts predicting a massive storm or daily medical decisions analyzing a scan, we are fundamentally dealing with uncertainty. But by comparing vectors in a high-dimensional space and simply selecting the closest neighbor, what feels to us like an AI taking a guess is actually a highly structured calculation of confidence. It looks at the geometry, finds what is closest, and uses that physical distance to calculate probability. Closeness literally becomes guidance. Ultimately, what feels like this profound, almost human understanding coming from a machine is actually a beautiful, carefully constructed geometry layered right over our language and our data. It is a clear, highly structured staircase from human observation through measurement and transformation all the way up to artificial intelligence. But here's the final thought I want to leave you with today. Since every intelligent system is fundamentally built on the features, the measurements, and the boundaries that we humans define on that very first step of the staircase, the real question isn't just what the AI is going to do. The question is, how responsibly will we choose to shape the geometry of our future? Thanks so much for joining me for this explainer.